Hello everybody, Blind Corn Dog here. Hope everyone's doing good. In this tutorial, I am going to show you an overview of Godot's animation player, and we are also going to incorporate an animation tree. These are very useful tools in the Godot engine, so let's get into it. Now, for the purposes of this video, I'm going to be using a character body 2D. I've already loaded a new project here, so I'm going to go ahead and add this. And then to get started, let's just go ahead and add a sprite. What we want to go ahead and do is just get basic movement down. All right, so before we get into tile sheets and the animation player, let's just use the built-in icon to make sure that we can get player movement correct. Okay, so let's go ahead and load in the icon, and it'll pop up right here in the 2D renderer. So the next thing we want to do is go ahead and attach a script to this character body 2D, and we will most likely get rid of a lot of the stuff here. Okay, so this is going to be like a top-down type of game with character movement. Now the reason I'm doing this is because I had much difficulty doing this on my own, and it was very frustrating, and it took me a long time. So let's go ahead and delete all of this. We do not need all of that in the physics process function. There is not going to be a jump. It's just going to be basic movement. We're walking around, and then we're going to incorporate some directions, rotating the sprite around and up, down, left, right. So I'm going to go ahead and get rid of all this. I am also going to go ahead and get rid of this guy because we don't need gravity. I'm not worried about gravity because it's a top-down game. That means that we can get rid of this guy too. So the first thing that we need to do is go into project, and let's go ahead and map our input functions. So to map input functions, we need to go to project, project settings, and you can see it here. Next to general, it's input map. Now, to add actions in here, add new action, you just call them whatever you want to do, whatever you want to call it. For simplicity, I like to just stick with up, down, left, right. So I'm going to go ahead and add up, and of course I spelled it wrong. I'm going to add down, I'm going to add right, and left. To map an input key to each of these, you just click this little add here, and then all you have to do, since this is the up, is just use the up. I'm going to use W. I'm going to use WASD for movement. So W, okay, you can see it here. Same thing for all these. Down is going to be S, right is going to be D, left is going to be A. Excuse me. So there we go. But if we try to do anything here at this point, save it, and nothing happens, right? Because we have nothing going on in our physics process. So what I want to do is add one simple line of code that will allow me to move around the screen, okay? So I need to add a variable here, and it's going to stand for the direction on the screen that the character moves, okay? It is going to be initialized to vector2.0 since this is a 2D game. Whoops. We want it to be 0. That means that the player will not be moving whatsoever. Now in the process, physics process function, when the game is running, this is constantly being read. We want to update that direction based upon the inputs, right? So instead of having a bunch of if statements that says if it's up, if it's down, if it's left, if it's right, we can do this all in one line, and we can also normalize it, which means that the movement will be equivalent across diagonals and such. So the direction, tab over here, the direction is going to be equal to an input. And what we're doing is we're getting a vector, which means which direction are we going? Are we going up, down, left, right? Or are we going diagonal and in between any of those directions? So get the vector. All right, and then we can list. You can see here, down, left, right, and then at the bottom here will be up. I'm not going to scroll all the way down there, but we just get all those, right? Left, right, up, down. I'm going to start with that. Left. Oh, poop happened. Left, comma, right, comma, up, comma, down. Now, the next thing we need to add is velocity, all right? Velocity is actually what is used to move this character around. So we need to update the velocity. Now, velocity is built in. You don't have to worry about making a variable up at the top for it or anything. So we want velocity to be equal to direction times the speed. Now the speed up here is built in. It's the default value. You can change it to whatever. If you up it, it'll be faster. If you lower it, it'll be slower. Now I'm going to add something to this direction line here in a second, but I just want to show you. So if you leave it like this and you run it, right? Moves fine, up, down. But what happens when you move diagonal? It goes a little bit quicker. So what we want is to normalize it. That is pretty typical for these types of games. You want to normalize it. Now the way you do that is you just type dot normalized at the very end there so that the movement is considered equal across all of the patterns. You want it to be normalized, all right? If you play games like Undertale, you can see that when you move in a diagonal direction, the character actually moves a little bit faster. That's because the vector is not normalized. I'm not hating on that game. That's a fantastic game. But that is one little thing that I noticed. And there's nothing wrong with it. So, we have our basic movement down. All right, that's perfect. That's what we want. The next thing we want to do is we can go ahead and add our animation player, and then I'm going to change the sprite. All right, so add a child node. It's going to be an animation player. Don't do tree. We can do tree later. So, the way we add animations, first thing we need is obviously a different sprite because this will be static across all movements. So I'm gonna change this. I'm gonna go ahead and load in a sprite sheet that I have created in Sprite. I highly suggest that you make your own. This character is 64 by 64. It might be a little big for your purposes, but it'll still get the job done. All right. So I'm gonna copy this guy over here, and I'm gonna put him in to our game. Just give me a second, and it'll pop up here, and then we can use it. All right. Excuse the name. I went through several different sprites. So I'm going to load in a new guy here. It's going to be this guy. Now, if I open it, you can see that this sprite sheet here has several different rows and columns. That is exactly what we want for the purposes of this. Each line represents a different type of movement. I do not think that I'm going to go through all of them, except for basic movement and maybe an attack. All right. So, in the animation player, click on that. You come down here to animation. You hit new. I think that it's important for certain games like this to have an idle animation, so I'm going to use idle. Now, my idle animation will literally just be my character just standing there. So there's no up and down movement like you see in good 2D games. I didn't feel like making something like that, so we're just going to roll with this. Now, if you use this slider here, you can zoom in on the length and the ticks of this. This represents the timing of the animation. Since this is an idle animation, you want it to loop, so I'm going to go ahead and hit this, and it'll loop. What I'm going to do now is I'm going to come up here to my sprite. All right. We can add all the other animations here in a second, but this is how you add a super simple basic animation here. Now, the next thing you want to do after you get that animation player up, maybe you want to do this before you get the animation player up, but you want to define how many horizontal frames there are in your sprite sheet as well as how many vertical frames there are on your sprite sheet, all right? It's just a grid. If I count these, I can tell you how many horizontal frames there are and how many verticals there are. So if I look at this, 1, 2, 3, 4, 5, 6, 7, 8. There are 8 horizontal frames. So I'm going to change this to 8. How many vertical frames? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10. Now, if I look at this now in the 2D renderer, you will see one single sprite. If I left it alone as 1 and 1, you would see this whole sprite sheet here, and that's a big no-no. You do not want that, obviously. You want to take one frame at a time. So what I'm going to do is I'm going to find the frame where my idle animation is, and I'm certain it is in my third row and the first column here. So this would be 0 through 7. This would be 8 through 16. This is going to be frame 17. All right, the first frame is always 0. So if I hit 17 here, I hit enter, I will see my idle. It's actually not 17. It is 16 because I did my math a little bit wrong. It's 16. You will see your idle character here. All right. I know I'm jumping around a little bit here, but there's one thing that I forgot. This looks kind of blurry. You go to project settings to change this blurry stuff here. And you go to rendering and then textures. And the thing that you want to change is rather than it being linear, you want it to be nearest, and it's not blurry anymore, which is great. Just a little side note there. Okay. So to add this animation, this frame to this animation, I apologize. All you have to do is find that frame and hit this button right here. That'll keyframe it. It'll add it to this animation here that you have pulled up. Make sure you have the idle animation pulled up. So if I hit that, just hit enter, and we're good. And it's there, okay? I want to shorten this animation significantly. It's 1 second long. It doesn't need to be 1 second long. I'm just going to make it 0.1 seconds long. And then you'll see that it is shortened there significantly, which is great. Now, the next thing. Let's worry about walking. So I'm going to add another animation. And there are going to be 4 different walks, right? I am going to use front walk, back walk, right walk, and left walk. So I'm going to start front. Enter. And I'm going to go ahead and add the other ones, and then we can add in the stuff. So back walk. Right walk. And left walk. Okay, they're all there. That's perfect. For me personally, what I like to do is make the length of this animation how many frames there are here. I just find that that works a little bit better with the math. You can adjust yours however you want to, but since these are snapped at 0.1, I'm sorry, the snap is down here. You can make it 0.05, you can make it 1, so you get 1 frame per second, which is a little silly. I like to just use 0.1, it's the default value. So what I'm going to do is make this animation 0.8 seconds long, because there are 8 frames in my walk animation. So I'm going to go ahead and do that for all of these really quick, and then I'll worry about putting in the correct frames for each of them. So let's start with front walk. The easiest one, right? So I'm going to find my front walk animation, and it seems I'm already there. I am at 16. And that line right there is my front walk animation. So I'm just going to go ahead and click in all of these frames. 1, 2, 3, 4, 5, 6, 7, 8. And we are done. That's perfect. Okay. Let's go ahead and do that for right walk, back walk, everything else. So the next one I'm going to worry about, since we're already on my back walk, is the back walk animation. So make sure that you reset this slider over, because when you just come on to a different animation, that this thing will already be at the end. So just make sure you reset that. It's kind of a pain in the butt, I understand. So just go ahead and keyframe in these 8 animations. 1, 2, 3, 4, 5, 6, 7, 8. All right, and we are good there. And now the next one that I'm going to worry about is my left walk. So my left walk seems to be at the very bottom here. So I'm on 32. This will be 40, 48, 56, 64, 72. So I'm going to change this to 72 and make sure that that's the right frame. We're good. Keyframe in those 8 frames. 1, 2, 3, 4, 5. And guess what? I didn't reset it. I told you to do it, and I did do it. So here we go. Now I have to reset to 72. All right, and then start keyframing those in. Okay. Go to right walk. Same thing. All right, reset that guy. 64. Okay, and start keyframing them in. There we go. Okay, so they're there. What the issue is still is if I look at this, I run it, there is no animation there. It's just my guy sliding around, having a good time, right? So what we need to do is create a function in the script that will handle all of the animations, right? In order for us to do that, you can do it directly with the animation player, but I find that the animation tree handles things significantly better. Okay, now the first thing you want to do after you add your animation tree as a child node, there's a couple things here. You want to assign the animation player to your animation player over here. That's important. And then the one that I use here is I use an animation node state machine, makes life easy. All right. This will handle all the states. You're going to add some conditions that will allow you to transfer between states. So from idle to walk and from walk to idle. And then if we add an attack, when we add an attack, that as well. Okay. So first thing we're going to do here is click this little add button. We're going to add an idle blend space 2D. Okay. We're going to make it blend space 2D. And change it to the cursor. I'm going to name it idle. I might move it around here a little bit. Can I move it? Yeah, there we go. Okay. And the thing that you want to do is drag this guy, click this little pointy arrow, and what it'll do, it points to the transition that is allowed. All right, so on start, you obviously want it to go ahead and be idle. You don't want the guy to be walking in place or anything like that. The next thing I'm going to do is I'm going to come into the idle, and I'm going to add some points. Now this is kind of weird because this graph is like a normal math graph. If you think about a video game screen, it's actually pretty inverted. Well, it's not pretty inverted. It is inverted. This is a normal math graph. So if I'm talking about the front of the character, right, I'm talking about this area here at the top. If I'm talking about the back, it's here. Left and right are still the same. So I'm going to add a few points here. Right here. I'm going to add an animation, and it'll be idle. Okay. I'm going to add another one over here. It'll be idle, idle, and idle. Okay. So if I click on all these, you can see that idle is there. Now, doing this made me realize that I forgot idle left, idle right, idle back. So let us fix that really quick, shall we? In the animation player, we need to add a few more animations. So, silly me. Idle back. Idle right. Idle left. Okay. And then snap those to be 0.1 long. Okay, so come to the sprite 2D and find the correct frame and add them to each of your idles. For me, I think this idle back is 24. Let me see. Yep, that is correct. I'm going to keyframe that. The other thing you need to make sure you do is hit on that looping, which is something that I forgot to do for all my walks.
So let's see, idle left here. Gotta find it. Pretty sure that is 72. That's correct. Keyframe it. Okay, idle right is 64. Keyframe it. Good. Okay. Make sure you set on looping for all of these. And that you don't want to mess with any of the discrete things down there as well. Okay, make sure I have all these on looping really quick.
Okay. So, now we need to fix in our animation tree the idle state. This right here should be, the top one should be, if I click on it, idle. The one to the left, guess what it should be? Idle left. The one to the right, guess what it should be? Idle right. And then this one down here will be idle back. Now you can see some craziness going on here. The reason for that is because it's trying to be continuous. You want it to be very discrete, and then the craziness stops. Yay, no craziness. Okay. Now the next thing we want to come back and do is come to this root idle, and we want to add in our next state. We have the idle state taken care of. We want the walking state to be taken care of next. So I'm going to add a blend space 2D. Whoops, that's not what I wanted to do. Make sure you click on it and you want to edit it. I'm going to make sure that this is walk. Edit it, and then the same thing, go ahead and change this to discrete so that we don't have that same craziness going on, okay? We're going to add some animations here. Since this is going to be up here, we want that to be the front walk. Since this is over here, we want this to be the left walk. Bottom is back. Right is right. Okay. I'm going to drag this guy down here a little bit because this is not actually all the way to the bottom. All right. So I didn't understand this earlier. Explain this earlier. So let me explain this. The input vectors determine which way the character is moving, correct? This graph reads the direction, essentially the direction at which your character is moving, so that it knows which animation to play. This saves you a significant amount of code. You don't have to have, if I'm moving left, play the left animation. If I'm moving right, play the right animation. If I'm not moving, play the idle animation. It just saves so much time. All right? So we want all of those to be like that. And then the next thing we got to do is add these to be connected, and then we got to add some conditions. All right? So obviously you see some nonsense going on here. The reason being is because there are no conditions. So what we need to do is come up here. We want it to be a condition. This is going from walk to idle, so we need it to be idle. All right. And then this one is going from idle to walk, so we need the condition to be walk. Okay. This will just be on start. So the next thing we need to do is we need to add a few things to our script. What I like to have is a function that updates the animation. So what we're going to make is a function called update animation. Okay. And it will handle all the animations. Okay. So there's a few conditions here. Basically, if we're not moving, we want to set the condition of idle to be true for our animation tree. All right. If we are moving, we want the condition of walk to be true and idle to be false. So let me explain this again. These right here, these arrows in our animation tree handle the conditions for going from idle to walk and from walk to idle, which is beautiful. All right. So let's handle not moving. All right. So if our velocity is equal to vector 2.0, that means we're not moving. All right. We want the condition for our tree, the idle condition for our tree to be true, and for walking to be false. So what I'm going to go ahead and do is access that particular condition. Now the way you do that you could make a variable up here that'll represent your animation tree. I'm just going to roll with using animation tree, accessing the animation tree. Okay. To access the condition, you type these square brackets here, and then we're going to give it the condition in the quotes. So if I click on animation tree here, I go to parameters. Okay. You can see them. Idle and walk condition. Now what you want to do is right click, copy property path. And you want to put some quotes. You want to put that in there. If we're not moving, we want that to be true. Okay? And we're going to do the same thing again, but instead of it being idle, it's going to be walk, because that's our other condition here, walk. It will be the exact same thing as parameters, conditions, walk. Just the name will be different. We want this to be false. Okay? So that's beautiful. So, there's only one other possibility here if we are not moving. I mean, it is, we are moving, so we don't need another if statement. It's just if we're not moving, we want to be in idle. Otherwise, we want the opposite to be true for each of these. So I'm going to copy these down here, and I'm going to switcheroo them real quick. This is going to be false. This is going to be true. And that'll handle whether we're in idle or whether we're in walking, okay? Now, the last thing I believe that we need to do is set some blend positions. The blend position is what helps the animation tree recognize which direction we are facing on the game. It's going to be another little if statement here in the update animation. It's going to be if direction is not equal to vector2 dot 0. Okay. We want to set the blend position of each of these animations to be the direction that we're going. Okay. Or the direction that we're facing if it's in idle. So what I'm going to do is I'm going to access my animation tree. And what I'm going to do here is copy this property path for the blend position of idle. And it also needs to be in quotes, which is something that I forgot. Okay. We want that to be equal to direction. Now this will be continually updating, which is fantastic. That's exactly what we want. It'll always be updating. So that we don't have to worry about handling it ourselves. The thing that we're going to have to do though is call update animation in the process function in a second. So the next thing we're going to do is do the same thing here, but instead of it being idle, it's going to be walk with a capital W this time because that's the way it's spelled over here. So what's the next thing we need to do? Well, this function is never called anywhere. We need to make sure that we call it, and it's being called continually throughout the game. So where should we put it? Probably right here. And if we run it and see, we are good. Check that out. That is fantastic. Everything seems to be working correctly. I can walk off screen. That's something that you don't want to be able to do. Alrighty. Wonderful. It is working correctly. So, that seems to have been a really long video. I think I will stop there. I hope that this has helped you significantly and that you can continue to pursue your dreams of creating games. This has really helped me making this video. It has reinforced the knowledge that I have gained. I wish you the best, and if you have any suggestions for me and you would like for me to do something specific, please let me know. In the next video, what I will be doing is adding some collision shapes adding some more animations to allow us to attack, because the attacks that I have made are kind of interesting, and I can guarantee that they will help somebody out. Blind Corn Dog here. Thank you all for watching.